Okay, so I'm trying to find the relative maxima for the equation f of x equals 3/5x to the 5th plus 12x to the 4th plus 60x to the 3rd plus 3. So first I need to take the derivative. I get 3x to the 4th plus 48x to the 3rd plus 180x squared. And I can further simplify, take out the 3x squared, make it 3x squared, x squared plus 6x plus 60 equals 0. So I know one of my x's is going to be 0. Now I can do the diamond problem for, no, this should be 16. Yeah, 16x. So now I can do a diamond problem. 16 and 60. I get 10 and 6. So equal to 0, make it negative. My zeros are 0, -6, -16. And now once you have your zeros, you're going to want to plug it into this map to find where it's positive and where it's negative. So you'd have -16. No, not -16. It should be -10. You have -10, -6, and 0. So now after plugging all the numbers in, you'd find that the maximum is at -10. Go. Okay, so for this, we're trying to find f, the derivative, and the second derivative with these three equations. So first, we have to look at the slope. So this one, we see it's negative from -9 to -5. So here, it's also negative because the value is negative. You see it's under the x-axis. So it's negative. And then here, going from here to here, is negative on the slope. And then once you get to -5, you're going upwards, and this is becoming positive because the slope is becoming positive. But this, the value is positive because you're over the x-axis, so you're going up. So that means that this is f. Yeah, that's f. And then this is the derivative. And then this is the odd one out, so it has to be the second derivative of f. And yeah, that's how you do it.
Okay, so for my problem, I'm going to make a true statement regarding the points f prime -7, f prime -4, and f prime -2. Here we have the graph. The points -4, -2, and -7. So the slope of the target line at x equals -7 is negative because the function is decreasing at this point. See the decrease. The slope at -4 is 0 because you have a local minimum. You see the point is at a kind of straight. And the slope at the function, at the point of the function x equals -2 is positive, it's going up. So when you put these values in order from smallest to largest, you get f prime -7 is less than f prime -4, which is less than f prime -2. Because this one is at a negative, this one's at a 0, and this one's at a positive. So when you're doing this kind of problem, you need to make sure you're looking at the slope. You see the slope at these points, not the points at the y-axis. So this point, this point, this point. You need to find the slope.
the intervals where f of x is concave down at f of x equals 1/3 x to the 6th minus 3x to the 5th. First off, we're going to want to find our f prime, which is our first derivative. F prime of x equals 2x to the 5th minus 15x to the 4th. Next, we're going to want to find our second derivative. So f double prime of x equals 10x to the 4th minus 60x to the 3rd. Now, to find concavity, we need to find the zeros of our second derivative. So we factor it out. F double prime of x equals 10x to the 3rd times x minus 6. X is going to equal 0 and 6. Now, we take x equals 0 and x equals 6 all the way up here, and we are going to do our second derivative test. First, we're going to plug in -1 to f double prime. Then we're going to plug in 1 to f double prime, and then we're going to plug in 7 to f double prime so that we can find whether or not it is concave up or down from the intervals -∞ to 0, 0 to 6, and 6 to positive infinity. So first off, when we plug in -1 to f double prime, we get a positive number. So that means that f double prime at -1 is concave up. Now we come down here, we plug in +1 to f double prime, and we see that it is negative, which means that on the interval 0 to 6, f of x is going to be concave down. From 6 to positive infinity, we're going to plug in 7 to our second derivative, which will come out to be positive, meaning that on the interval 6 to positive infinity, f of x is concave up. Now, we have our concavities here. Because there is only one negative on the interval from 0 to 6, we can see that